Hello, welcome to the Code Physics channel. Today I want to continue with our topic of electronics, and we are going to look at specifically a part known as rectification. So sit back, relax and enjoy. Rectification is defined as the process of changing alternating current to direct current. When you talk of alternating current, it flows in both directions. For example, we have a current here that is moving. As we can see, it is moving up and it is also moving down. Now, a current that is moving like this, it is known as alternating current. Direct current flows in only one direction. As we can see here, it is moving only upwards above the x-axis. Okay, it does not move below the x-axis. Now this current which moves in only one direction is what we call direct current. Now diodes allow current to flow in one direction. Okay, and because they allow current to flow in one direction, they are used in the process of rectification. In other words, diodes are used as rectifiers because of the fact that they allow current to flow in only one direction. Now, there are two types of rectification. There is number one, what we call half-wave rectification, and half-wave rectification is shown below. So, when you talk of half-wave rectification, we are going to be using only one diode. Okay, have an input waveform. This is AC. Okay, and it is put into a transformer. This is a symbol of a transformer here. So here we are having a transformer. Okay, now because this is AC, it is going to be flowing in two directions. Sometimes it's going to be moving up, sometimes it's going to be moving down. So if it is moving up, as you can see, it is at point A here. Okay, at one time it is going to be moving in that direction, another time it is going to be moving in this direction here. Now, when it is moving up, A is going to be taken to be positive and B is going to be taken to be negative. Then, when it is flowing in this downwards towards the side of B, then B is going to be positive while A is going to be negative. Okay, now let us start assuming that the current flows in the side of A. It flows upwards here. Okay, it means that here it is going to be positive. Now, as we can see, if this is positive, this positive part is going to be connected to the anode, and then the negative part is connected to the cathode through the resistor. So in this case, we find that this is the positive is connected to the anode, and therefore we have a forward bias, and in forward bias current is going to be flowing. The diode is going to allow current to pass through. Okay, so at the first case, let us start by current moving upwards. I mean the up part is positive. That means that we have this is positive connected to the anode, and so current is going to pass through. It passes through, it passes past the load here, and then it goes back to the transformer. Okay, so in the second case, we find that B is going to be positive with respect to A, and if B is positive, that means that current is going to flow from here. It passes through the load and then it comes and meets the cathode. But now the problem here is that when I have the positive of the voltage, okay, coming to the cathode, then we are having a reverse bias. And if I have a reverse bias, current is not going to flow. So in this case, when this side here is positive, the current which is flowing downwards is going to be cut off. Whereas if it is moving upwards, it is going to be flowing. Okay, it is going to pass through the diode. The upper parts, it is going to be positive, current is going to pass through. Okay, down part, if it is positive, current is not going to pass through. And this happens for every half a cycle. In other words, for the first half of the cycle, okay, this upper part here, this is going to be positive because it is moving, it is flowing upwards. In the next half cycle, which is downwards, current is not going to pass through the diode because it is going to be blocked. Okay, and then in the next half cycle, again it is going to be flowing upwards. Therefore, current is going to flow. The next half cycle, it is downwards. Current will not be flowing. As a result, we find that we are going to produce an output where we are having a waveform here where it is upwards, but the down part has been cut off. Okay, because the down part is not allowed to pass through the diode. And then this one here, again, it is going to be moving like that, upwards, but downwards we don't have something. Full wave rectification is achieved by using a diagram shown below. In this diagram, we have two diodes, that is D1 and D2. We also have another common point that is labeled O, and this point is known as the center tap. It is found at the center of the secondary windings of the transformer that is being used here. It is going to act as a common point for the current to pass through after passing through diode D1 and diode D2. In our input waveform, we find that there is the first half cycle, it is positive and it is facing upwards, meaning that point A is going to be positive. And if point A is positive, that means that we are going to be having a forward bias, since this is the anode and here is also going to be positive. The voltage here is positive. Okay, so if that is the case, then diode D1 is going to conduct, and if it conducts, current is going to pass through. It comes here, it reaches this load here, it passes through the load, and then it goes back to the center tap. In the next half cycle, we find that it is the down part, okay, the half cycle, which is downwards. So this implies that this point here is going to be positive. Okay, so that means that this diode here is going to be conducting, since we have a forward bias. And if we have a forward bias, that means that the current is going to come, it passes through the diode, it comes, it passes through the load, and then it goes back to the center tap. Now the current, when it reaches here, it cannot go this end here, it cannot pass through this diode here, because in that case we shall be having a reverse bias. Okay, and when it's a reverse bias, current cannot pass through. So in the first half cycle, D1 is going to be conducting, and then it produces this waveform. Okay, in the second half cycle, D2 is conducting, we produce this half cycle. So for every half cycle, the first half cycle, D1 is conducting, second half cycle, D2 is conducting, third half cycle, D1 is conducting, fourth half cycle, D2 is conducting, and the process continues on and on and on. Now the DC that we've produced is changing. Okay, as we can see, it is going up, down, it is up and down, up and down. Now in this form, it cannot be used in electronic circuits. We have to work on it in such a way that it becomes smooth, like that one which is produced in a battery. This is the DC that is produced by a battery. Now if you look at this diagram here, okay, we find that the DC that is produced here is smooth, it is pure. Our DC that is supposed to be produced after rectification should be almost the same as this one here, though it may not be exactly that. Okay, and to achieve this, we are going to use a capacitor. Okay, so we have our capacitor C2, And this capacitor is connected in parallel with the load where the DC is going to be produced. Now when the capacitor is connected to the load, we are going to produce our DC in this form. Okay, it is almost going to be pure, though it is not pure. Okay, it's not like the DC that is produced by a battery, but it is almost equal to that. It's almost nearing that. Now this process where we bring a capacitor and connect it to the load such that the DC we are going to produce is smooth, is pure, is what we call smoothing. And in other places it is called filtering. Full wave rectification can also be achieved by using a bridge rectifier. A bridge rectifier consists of 4 diodes connected as shown in the diagram below. Okay, so these are our 4 diodes. There is D1, there is D2, there is D3, and there is D4, and they are connected like that. Okay, now for the first half cycle of the AC that is going to be rectified, we find that point A is going to be positive, meaning that current is going to be passing up, and when it passes up, it is going to come and pass through D2. Okay, it passes through the load R, and then it comes like that, it passes through D4, and then it goes back to the transformer. In the second half cycle, the upper part is not going to be conducting, it is the down part that is conducting. And in this case, we find that the current comes, it passes through D3, it passes through the load, and then it comes to pass through D1, and therefore it goes back to the transformer. So for every half a cycle, 2 diodes are going to be conducting, that is D2 and D4, and then the next half a cycle we have D3 and D1. This process is going to continue, okay, and this is going to be produced on the other end.